Well, firstly, I'd like to say thank you to everyone who's registered and joined us today. My name is Thomas Carmody. I'm responsible for product management and business development at CODICO for our business with Qualcomm. We are going to talk about Edge AI today, and specifically how to scale up and rapidly deploy Edge AI use cases in industrial applications, so factories, warehouses, that kind of thing. Okay. So just a brief few words about the agenda. Well, maybe I should stop and also say that I will present the first part of the webinar, and I'm also joined, I'm delighted to say, joined by Mo Sani, our Senior Solutions Engineer at Qualcomm, well, at Edge Impulse, a Qualcomm company, and both myself and Mo will be conducting the webinar today. Okay, so just a few words on the agenda. I'm going to make a short introduction to CODICO, what we do, try to keep that brief, and then we will talk a little bit about automation, and specifically the topic we're covering today is camera-based or computer vision and AI-based automation. So I'm going to talk a little bit about the industry, the trends, the forecasts. I am going to talk about what we see as the opportunity in computer vision automation. We're going to introduce a very, how would I say, an SoC which is ideally suited for this kind of application in the Qualcomm Dragonwing processor family. I'm going to introduce a new solution that CODICO and our partner JMO have developed based on that SoC technology, Perspec. And then I will hand over to Mo, who will introduce an end-to-end AI development environment from Edge Impulse that brings our Edge AI solution to life. Okay, we're also going to include today a demonstration, a video demonstration of the Perspec solution running the Edge Impulse trained models. Once we're done, we will conduct a wrap-up. If there are questions, people can put the questions in the chat window, and my co-hosts here will try and answer those questions as we go through the presentation. If there are a lot of questions at the end and we have time, myself, Mo, and our senior FAE, Nico, will try and answer the questions live. But we will, suffice to say, we will try and cover all of the questions either online or offline. Okay, so just moving into the material, I want to make a brief introduction to CODICO. Just to say a few words, we're a family-owned business focused on design in distribution. We've been in operation since the late 70s. CODICO happens to be Qualcomm's largest partner by revenue in Europe, and that's a function of a long-term relationship. We've been helping Qualcomm to commercialize their cellular connectivity processing, wired connectivity technology for over 20 years. The focus at CODICO is delivering technological innovation to our customers. We're all engineers here. We work closely with partners to deliver new technologies to our customers. CODICO is a pan-European business with a footprint in all the major regions, and we have quite a large customer base throughout the region. So what it is, just a few words to set the scene on this webinar. What we are working on, what I do at CODICO, we help customers develop products of the future. So we do that by leveraging market-leading technologies. In my particular area at CODICO, on the right-hand side, you can see intelligent vision, robotics, drones, intelligent displays. These are the kind of projects that we are working on. We take, as I said, market-leading technologies. The Dragon Wing processors are a good example. These are long supply industrial grade SoCs with high levels of integration. We'll talk about that later, but market leading performance when it comes to running AI workloads on the device. In addition to the core technology, the processing technologies, we complement that at CODICO with communications, wired and wireless, to deliver mission critical connectivity for robotics, drones, applications over distance and in extreme environments. We don't do this alone. We rely on partners where we've established long relationships who help us to complement our customers' capabilities to develop products. Okay. In terms of just a final few words, the development of multi-sensor mobile robotics, smart displays, handhelds with edge AI capability, the complexity is large, the costs can be large, the time to market can be long. So we look to take certified solutions, system on modules, SBCs, custom PCBAs from our partners, and we combine that with engineering services, again, to define projects to complement our customers' capabilities and work together to deliver the products that I talked about earlier, and you can see in the diagram here. Okay, so that's a short introduction. The purpose of today's webinar is really focused around automation, and specifically camera, computer vision, AI-based automation. Taking a step back or a step up and looking at the automation market overall around the world, it's a very significant market with a very fast growing trend. Of course, the automation or the need to use machines to replace a human workforce or to complement a human workforce is something that we see across the board, across industries. And there's a number of reasons for that. The underlying technologies, cameras, AI, robotics, connectivity, the advancements in those technologies has been stark. It has been quite impressive in recent years, combined with cost reduction. So, of course, these technologies are seeing more and more adoption. We do have situations where skilled labor is scarce or it's costly, which is another driver for this technology. But equally, and I'll talk about this in later slides, adding cameras, high-speed, high-resolution cameras to manufacturing a warehouse location can drive a certain amount of efficiency. It can improve quality. So there is a lot of benefit from a productivity efficiency perspective. And also, when you have continuous monitoring of your production, your manufacturing, your assembly, you're reducing costs also. You're reducing waste, reducing energy from rework and such things. So those are some of the key drivers. In regards to where automation stands or how the important economic regions look at automation, suffice to say, every major region, China, US, and Europe, have strategic initiatives to encourage companies to adopt more robotics, more camera-based automation technologies into their manufacturing. or into their work processes. Drilling down to Europe a little bit, just a few words on Europe. The market, again, is quite large with a strong growth. The drivers are very similar to the global drivers for automation. I should point out, I suppose, that sustainability is a very significant focus area in Europe, and something that automation can deliver on. There are a number of unique challenges in Europe that have to be tackled to, how would I say, to allow or to enable the industry across the region to broadly adopt these technologies. I've highlighted a few of those challenges here. What CODICO and our partners have been thinking about is how to deliver practical solutions that are more accessible in terms of cost, in terms of technical complexity, and I'll show you what I mean by that in the coming slides. Okay. So again, as I said, our focus is, we've identified in the automation space an opportunity for a new form of computer vision and AI systems, replacing legacy equipment that's broadly rolled out in manufacturing in Europe. And specifically what I'm talking about is legacy computer vision systems that are rule-based. These systems have been installed for the past 10 years or more. They are typically large Intel-based compute platforms with custom FPGAs running custom image signal processing pipelines. The computer vision software to check the orientation of labels, to check the quality of the production line output. That software is often proprietary. It's rule-based and quite inflexible, so it requires tuning if there are any changes. There is a small install of AI accelerators in these products from Halo and NVIDIA accelerators we see, but that's a limited install. So the opportunity as we see it is for industry to transition to a future which is, to transition to an architecture which is all-in-one compute boards, leveraging the latest SoCs, which highly integrate the compute, the camera ISP, the MPU into a single device, moving from proprietary software to a more open source based architecture. The SoCs incorporate the camera ISP. Therefore, we can reduce the complexities of the camera modules that are placed around the industrial environment. So you can reduce camera complexity and cost. And we can combine the existing software, rule-based computer vision software that's well established, that has been working well for the target application, and we can enhance it now with deep learning and machine learning running on the embedded MPU in these devices. Suffice to say, the hardware has to be complemented by an end-to-end AI development tool chain to simplify the tasks of delivering working models to the factory, to the warehouse. So I talked a little bit about the opportunity. As I said to you earlier, CODICO is a long-time partner of Qualcomm, focused on delivering technology first to our customers. I'd like to say a few words about a platform that we think is a good base for the future computer vision automation systems, and that's the Qualcomm Dragonwing family. So we're talking about a family of SoCs developed specifically for industrial applications by Qualcomm. We have a high degree of integration. So as I mentioned earlier, high performance compute, high performance AI, high performance camera ASP function, and other things embedded in a single device. Industrial grade reliability. So these parts have been built with extreme use, extended temperature range in mind. Of course, those devices need to be provided for extended time frames, and so long supply in terms of hardware and software is provided. But most importantly, performance, and specifically the market-leading edge AI capability and current consumption. As I mentioned to you earlier, this is a family of devices. So we're talking about scalable compute, scalable MPU, scalable camera ISP. So we're going from, let's say, 10 tops of AI performance up to, with the latest Qualcomm Dragonwing IQ9 processor, we have 100 tops of AI processing for your edge applications. These devices, so with that kind of performance, you can run advanced AI workloads, including large language models, which opens up some interesting use cases for industrial machines. And just a final few words, we're talking about a Linux first philosophy, including support in some of the Dragonwing SKUs for real-time operation under Linux. These devices are, of course, supported by the Qualcomm ecosystem of partners, so there are plenty of experts available to support customer applications, and there is a very rich and comprehensive set of documentation software to support these devices. Okay. I just wanted to show a very brief video in my final few slides here. This is just an example of an automation case leveraging a Qualcomm Dragonwing SoC, the QCS6490. This is a high-end SoC from Qualcomm already in production. In this particular application, which is something our partner JMO has collaborated on, the purpose was to automate the process of monitoring fabric production on existing Toyota looms in operation in a factory in Asia. So there's 6 cameras on a gantry. In the second picture, you'll see a gantry. That's a single 6490 camera running at high speed, high resolution, with the fabric loom running at full speed. And the purpose of the cameras, there's a coordination between the cameras. The purpose of those cameras is to capture defects in the fabric production. And if they're serious enough, the human operator can intervene to address the error. But essentially, this particular factory is producing fabric with a higher quality, with less waste, and there is also less in terms of the shift pattern. The human resources are also reduced, which is a cost saving and a quality increase for this particular factory. And this is the kind of use case that we're interested in enabling our customers with using the Qualcomm Dragonwing SoCs. So a final slide before I ask Mo to jump in. We have At CODICO, we've identified the opportunity for computer vision automation and moving, as I said, legacy electronics to a new standard. And we have developed a solution based on the Qualcomm Dragonwing SoC called Perspex, so Parallel Recognition and Inspection System. This solution this particular solution was developed in collaboration with our partner JMO, again specifically to address the challenge of customers adopting computer vision automation in their warehouse, in their factory. We've developed a rugged solution that can be installed as a pilot or an early prototype. The hardware is a combination of the Qualcomm Dragonwing SoC and three high-resolution Sony sensors. So we can capture high-resolution, high frame rate data and offer that to the Edge Impulse end-to-end AI environment to allow a customer to quickly train and deploy AI applications without huge costs, without taking a long time. This particular Perspex solution is a family of products, so we intend to make several Perspex solutions. What you're looking at is the Perspex 1. We have a new version where we've improved camera connectivity coming soon. And also we imagine customizing this solution for specific applications. Customers may come to us to ask for a change of interface, camera sensor, or upgrading the Qualcomm Dragonwing. That is all part of maybe a customization service that we will offer in the future. So to bring this solution to life, we need a very compelling end-to-end AI development environment. And now I will ask Mo to introduce Edge Impulse and to offer us an introduction to the technology and to show us how he can bring, or how Edge Impulse can bring, the Perspex solution to life. Okay, Mo, I'll stop sharing. Yeah. I'll let you share.
Yeah. Hello, everyone. Thanks for joining the webinar. My name is Mo Sani. I'm one of the solutions engineers at Edge Impulse that recently got acquired by Qualcomm. So in this session, we're going to talk a little bit about why we need Edge AI, and then move on to show different features of our platform. And then I'm going to show you a little bit of a demo of how to use this CODICO JMO triple camera platform that is integrated with Edge Impulse. So if you think about Edge AI, why do you actually need Edge AI? There are like 6 main reasons for you to want to use Edge AI. The first one is innovation. A lot of new things need AI on the edge to be smarter and faster, to be more reactive. If you want to have more privacy, Edge AI means your AI runs on the edge, doesn't need to transfer all the information to the cloud, and your information and data stays with you. It is more power efficient because normally transferring data to the cloud and back requires more powers. Normally data transmission is the powers hungry part of the system. Therefore, it saves you costs, plus your server costs are going to be lower. Then you need your system is more reliable because you're not prone for like internet disconnections or server outage or anything like that. You're solely relying on your own edge device. And bandwidth and latency. When you're sending data to the to the servers and waiting for the response back, there is always a latency. And a lot of the low latency applications, critical applications, let's say you're detecting a fault, you need to shut down a system. We have a lot of that sort of use cases with our customers, and that's the main reason you need low latency, because you want to act immediately. Now, what is Edge Impulse? Edge Impulse is a company that allows you, we are a software company that allows you to build real world data sets, collect your data, build a machine learning model quickly, and then most importantly, deploy it back to the edge device. And so far we have 200,000 developers. That's growing, this numbers very, very fast. And we have 400,000 projects that there are people have built on the platform. Some of them are public as well. You could have a look and reuse that project as well. So we're building an ecosystem of edge AI algorithms. Now, how Edge Impulse solves the Edge ML problems is we have a few main problems in the tech world these days. A lot of sensor data. Everyone has multiple sensors in their machines and multiple ways to observe the environment, say camera one or IMU sensors, but they can't normally absorb all that data and get the most of that data, because they just take one, let's say one inference out of it, and then the rest is going to be discarded. So by having Edge ML, you can make more use of that data that you have in your machine. Tools, current Edge ML tools are not really suitable for, well, Edge ML. A lot of ML tools are bulky and they produce big models that they're meant to run on computers and servers. We are doing this transformation and compilation of models in the most efficient way that allows you to run your algorithms on the device directly. If it has hardware acceleration or not on CPU, or MPUs and GPUs and different sorts of things. So we are just expert on those sorts of hardware tools to make sure your algorithm runs as efficient as possible. A lot of AI ML projects fail because the complexity is more than what people think. A lot of people see, I don't know, some PyTorch, Keras projects, download it, start going open source, DIY methods. Normally, those things are good to take you quickly from 0 to, I don't know, 70% of the project. But then once you get there, a lot of complexity starts to ramp up, and we try to take you from 0 to 100 by providing all the tools that you need. And generally, these things are hard, and building a product with Edge ML is hard. So by using Edge Impulse, you're gonna basically save your man hours and your engineering work to focus on the right thing and focus on your own product and your own challenge. So in a nutshell, Edge Impulse at a high level, we have tools to monitor your devices. We have tools to manage your devices and collect data from your devices, and then start building your model, build a high quality data set, then train a model, and then optimize that model towards the edge. So this is the whole ecosystem that runs in a loop. If you look at it in a larger ecosystem of Qualcomm features, Edge ML sits nicely in the middle. You have the real world data coming from all sorts of sensors. We deal with vision-based sensors or non-vision-based sensors that are time series, temperature, IMU, anything. We have some foundational models, some of them open source. You could bring them into the platform. We have that feature, or some of them are developed by Qualcomm's research. Then you have the edge device ecosystem, either developed by Qualcomm or we are an open platform. You could use it on any other target as well. So you have multiple options to go there, but then you also have the deployment features of, we have another sister company, let's say Foundries.io, that allows you to easily manage the fleet of your devices. Then once you have everything ready, we have tools, VS Code extensions to test your model, and developer kits that Thomas talked about, that the PressSpec one is one of them we're going to talk about now. Now, how does the platform look like? This is one of the views. In my video, I'm going to show you more about the platform. By the way, if you haven't signed up to Edge Impulse yet, it's free to sign up and test it. So go ahead to edgeimpulse.com and open an account so that you can follow the videos with me together to build a model quickly. If you wanted to follow the next section, that's coming up in 5-10 minutes. But generally, you're going to see that it's a very nice, user-friendly way of developing models. We have this workflow of pick your different stages of, we call them impulse. Impulse is a larger terminology for having the things needed to run a model on the device, because it's not just the model itself, it's the pre-processing, spectral analysis, cropping, like shifting your images or pre-processing your data, and then post-processing as well. So we are trying to build that all together in a pipeline, and you can just click and select them in the platform. We have some we have some models developed on by Edge Impulse, because we felt the need in the market. There was a gap in the market. A lot of the open source, let's say object detection models, for example, were too large to run on the edge. So we come up with our own called FOMO model. This is a very lightweight object detection model that runs faster than the ones on the market, and you can even run this on microcontrollers like ESP32s and things like that, or Nordic chips. But also we have our own YOLO model. YOLO is a famous object detector with bounding boxes, but the free one that people think it is free on the market is not actually free, and it has license terms and conditions. But therefore, we are developing our own that our users can use it with peace of mind. Another very interesting features for industrial inspection use case is visual anomaly detection. A lot of the industrial use cases evolve around the fact that you have some products and you want to detect if something is wrong with them. That's a very common use case we help our customers to deal with, and we have a model developed as a block. You could just select it and upload some pictures. The good thing about this model is that you only need to train it with normal pictures, like good pictures of the products. So if you have, you're producing some plastic parts on your conveyor belt in your manufacturing line, you only need to take pictures of the good parts. Normally, finding the defects and taking pictures of them is hard, because you can't really predict what defects are you going to see. therefore this algorithm is quite robust and like picking up anything that is deviation from that normal data set that you uploaded. And it will show you where in the product it thinks there is a crack or there is a, you know, bad mold in the plastic or a crack on the plastic or anything. This is a sample project. We're detecting rust on this valve. And we have, again, two types of this FOMO AD algorithm, which one of them is more recently released. It's called HD version of it, which is more has higher resolution, so these pixels can go smaller and pick finer details in there. We have, I'm not going to show you all of the features we have on the platform. Go ahead and have a look. There are documentations and sample projects, lots of videos we made. But another one is, you know, object tracking plus cropping, object detection, and then doing anomaly detection on a conveyor belt. This is a very common use case. But normally, again, it looks simple on paper, but it is multiple things you need to have together to work together to achieve a good result, which one of them is object tracking as well. You need to track the objects and then crop them. It's not just a snapshot. We have that feature released as well recently in our platform. Now we have shown this demo in Hannover Messe earlier this year, and it was very popular by our customers. This is the same board, Perspec one. This was an Android version of it. We released there. It's doing an object detection on this screen, and then doing anomaly detection on the detected coffee capsules to show the possible anomalies on it, if they have any, like dents or cracks on the coffee pods. We now have a newer version of this available that's running Ubuntu, and I'm going to show you a video of how to collect data, how to train a model quickly, and then build an anomaly detection model that's working on these valves. As you can see, we have a data set, and then we'll do an anomaly detection. If something is wrong, there is a crack, if something is missing, as you see in this picture, the nuts are missing on both sides. That's picking up as an anomaly. So I'm going to go ahead and share that video and hope you enjoy it. By the way, in the meantime, if there are any questions, drop them in the chat. I'll get back to you. The first thing you want to do after you log in is to set your time zone, depending on where you are, just to make sure everything is in order. And then you can go ahead and install Agentpulse CLI tool. And that's just one-liner command. You can find it in our documents. and this will download it, and then you need to do sh and execute this file to install it. It will take a little bit of time, but eventually it should just work. Okay, the installation is complete now, and we just need to source this profile. That's it. Now you should be able to have Edge Impulse Linux available in your tools. Okay, at this point, I want to make sure you all have an account on Edge Impulse. So if you don't have an account, you can just create an account for free. Just click on Get Started, and very quickly you can have a personal account. Any type of account would be fine to follow these instructions. Here, I made a new project, fresh, brand new project to follow these instructions and show you how to do this integration. So, and also I've selected Qualcomm Dragonwing on the target just to make sure the profiling is going to be right for this target. So after you have an account, you need to run this command, simply Edge Impulse Linux, and then put your email address. Then boom, you should see the list of project, and you can search for the project you want to connect this board to. So I'm going to select this fresh project that I created, CODICO demo, and my board should just recognize 3 cameras. This CLI tool automatically recognizes this board that it has 3 cameras. So it will give us an option of selecting whichever we want to connect to the platform, to the Edge Impulse platform. I'm going to select camera 0, and boom, you should automatically see this device appeared here. I will give it a name. You can give any name you want, and now either click on this link or go to the data acquisition, and you should see an option to select the cameras. So this is my camera 0. I'm going to I've collected some more data here to build an anomaly detection model. As you can see, in the training set, I only have good models, good data, with no anomaly. And in test set, I have some anomaly and no anomaly data. As you can see, now what I'm going to do, using Edge Impulse platform, you can easily build an anomaly detection model. The first step is to go to create an impulse. Impulse is essentially an AI model with multiple elements in there. So first, I'm going to change the size to 320 by 320 to make the image a little bit larger and fit the longest axis here. And I'm going to select processing block of image. This will pass an image to the learning block. And then I'm going to pick visual anomaly detection as a learning block. And that's it. Save the impulse. Next, let's go to the image section. We don't need to change anything here. If you wanted to change the color depth, you can do it and try that, but I'm going to leave everything as default here and generate some features. Okay, our feature generation is complete now, and in a few seconds we should see the feature explorer being populated by a diagram. Yes, so you can see the distribution of the features in the space. Obviously, all no anomalies because that's how we train. Then you come here, we're going to use the EfficientNet and the patch core algorithm for anomaly detection. Leave everything as a default. I'm just going to add a 0 here to the sampling ratio because we increase the grid size to make this run a little bit faster. That's it. Now I can save and train. Okay, the training is complete now, and the performance metrics are going to be ready in a second. Before that, I wanted to go to the model testing section and try to classify all. Okay, model testing is finished now, and we can see the accuracy score of 90%. And you can see some of the samples to see these are no anomaly. Oh, let me move this screen out of the way. You see no anomaly here, classified correctly. And some anomalies, yes, you can see classified correctly. This is missing the bolt. And these are classified wrongly. Yeah. Right. It's possible to avoid these by adding more data and improving your data set. Now, I wanted to quickly also show you the inference time. The metrics are ready now here as well. In the training section, you can see inference time and flash usage for this algorithm on Qualcomm Dragonwing QCS 6490. Now, once we're happy with everything, we come to the deployment page. We have a variety of options to deploy this. What I'm going to show you is ARX64. This is the generic Linux executable and EIM file that bundles in the Edge Impulse SDK together with the model, and it has the pre-processing, everything together. This is one option. You could also try this one if you have Qualcomm neural network accelerator libraries available in your board. That's the topic for another conversation. You could either try to download these files from your browser and copy it over, or you could go to that board, use Edge Impulse Linux runner. There's another variant called runner. So you use this, and you could directly run it or use this to download. So you see multiple options. So I'm going to use the runner directly to run this. It's going to ask, I'm going to go ahead with unoptimized one. Okay, I'll scroll up. You can see a link here. If you just click on this link, it will give you a web page, a local web page. It's if you pay attention, it's the IP address of your board, and it's just showing the live stream of the camera with anomaly detection running on the machine, on the device, and you can see the inference time, 4 milliseconds for each inference. And this is the live stream. So I'm gonna try to move, as you can see, moving this back and forth. I'm gonna put another sample in there. This has no anomalies, as you can see, a perfect sample. And I'm gonna put, again, anomaly, sample, turn it around. It's a very quick model, but it still works really, really well. Okay, I tried to run 3 different models and 3 different terminal windows here. And I configured each of them to use a different port. So you can now see 3 different models. The top one is presenting in port number 1111. It's an anomaly detection model. It is running live, as you can see. And then the second model and the third model, yes, third model here. It's a classification model. It's running here, again live. And then the second model is object detection model with bounding boxes. We have multiple object detection models available. This is the one with bounding boxes. And this is again running live. So from here, you could take this and do anything you want with your projects. Right, that is the end of the video. It was a very abrupt end. Thank you very much for watching. Back to you, Thomas.
Thanks a lot, Mo. So what Mo is trying to show you there, as I explained earlier, maybe just to finally share share my screen here. So we're just trying to show sorry, get that right. We're trying to show the as I discussed earlier, right, there is quite a big opportunity to leverage technologies such as the Qualcomm Dragon Wing to address the need to replace stations on a production line or in a warehouse with camera systems that can do automated quality control, inspection, that kind of thing. And Edge Impulse environment brings that to life. So, you saw the 3 cameras, the 3 different models in operation, all executing on the Perspex kit. We imagine Perspex being something that our customers can use to quickly create a pilot, to test a pilot or a prototype of automation in their business. So it's taking one step above a development kit. This is a complete platform with powerful software from Edge Impulse to run the AI workloads the advanced AI workloads that customers will need for such applications, right? So as Mo said, thank you very much for your time today. If there are any questions, I'd encourage people maybe to add their questions into the chat window here in the final minutes. We'll try and answer those. Alternatively, you can make contact with us at CODICO, and we can handle your questions or your inquiries from there. I will, of course, CODICO, we will make the material that we presented today available. We will, and also the recording of the webinar content will be available to those who joined and those who could not join us today. Okay, so I'll just wait a moment to see if we've any questions. I see one question on kit costs from Hannes. Thank you. Hannes, there's a link on the QR code here. You can see what the kit costs from there. It's on our online web store, so you can purchase it directly from the web store. Yeah, it's 1,999 euros, I think. Yeah, but please check that. Take a picture of the QR code. Yeah. Any other questions before we wrap up? As I said, you can make contact with us afterwards if you have questions later on. But yeah, you will see Perspec in action in several upcoming events in the UK, in the US. So we'll be making videos and showing people what's possible using the solution. Okay. All right. So I think I don't see any more questions unless someone raises their hand. I can unmute you, and myself or Mo or Nico can try and answer your question. Give that a moment. Okay. And of course, we'd encourage you to take a look at the Edge Impulse environment. Perspec is compatible, but there are also other single camera development kits, such as the RB3 Gen 2. We've got some other kits as well that are compatible with Edge Impulse, so I'd encourage you to register on the Edge Impulse platform for free. You can test Edge Impulse without using any hardware. You can investigate. Then if you're looking to deploy single camera use cases, we can help with that. And as we described today, the Perspec solution is offering you a three camera anomaly detector or inspection control system. Okay. All right, so no more questions. In that case, I think we will wrap up for today. I would like to thank everyone for your time to participate. Materials will be available afterwards. I encourage you to come back to us if you have any questions. Okay, and with that, I think we will finish. Thanks, everyone.